Hi there, welcome to Taxonomy Online Mathematics. In this video, I'll be taking you through logarithm equations. In the previous editions, we talk about concept of logarithm. We deal with how to simplify, how to evaluate. But in this episode, we are going to deal with logarithms that involve equal sign. Meaning there will be log at both sides of the equal sign or one side of an equal sign. Now there are two methods involved in solving this question. The method one, what we do is that you make sure each side of the equal sign have a single logarithm. That is, of course, applying the product rule and that of the quotient rule in order to simplify them to be a single logarithm at both sides of the equal sign. So if you are done, so we can say that if I have log b base a in the first part, then log c base a, what we do is that you have to make sure the bases are the same. If the bases are the same, after I finish simplifying, I can say this is a single logarithm, So if this equals to this, then we can equate b to be equal to c. After you express both sides to have a single logarithm, then you are going to say the argument in the left equals to the argument in the right. That's the first method. Now, the second method is that you are going to have only one single logarithm in the whole equation. In the entire equation, to have only one single logarithm. Meaning you can decide to move them from the left to the right. If it is moving from the left to the right, if it is positive, become negative. Then in that case, we can employ quotient rule. So you're going to have a single logarithm in entire equation. Then if I have a log b base a equal to c, then I can express that a exponent c should be equals to b. Then I solve. In each case, I will solve to find the variable. You know, this is just a simple way without any logarithm. This is also going to be a simple way. Since this is a base and exponent, we can still express and get our variable. So these are the two major rules or methods we are going to use in solving questions under logarithm equation. Let's start by taking an example. Alright, so in this, we have to solve this. We are looking for the value of x. I said in the beginning that the log must have the same base. If not, you have to employ the change of rule. So since I'm having the same base and I'm having minus, I will decide to group them. The logs will come to one side in terms of like terms. So maintaining the left, log x base 2. This is coming as negative, become plus log x minus 2 base 2, leaving the 3 as we have there. Now, if I want to employ the second method, that is getting only one single logarithm in the entire equation, I can see that this is addition. So I am going to multiply the argument. So that becomes log x minus 2 base 2 equals what? 3. So you can see that I'm having the same part of it. Log b base a equals to c. Log this can be expanded. Base 2 equals to 3. So in this case, I will say that 2 exponent 3 is equals to I have x squared minus what? 2x. Per movement from logarithm to indices or to exponential indices, I'll get this. This is already just expanding of the bracket. So what will I do? This is going to give me 8 equals to x squared minus what? 2x. So what do we do? I'm seeing x squared single x. So I need to send the constant. So have x squared 2x minus 8 equals what? 0. So you can see this is a quadratic equation where we will be needing the factors of negative 8. When you add, you get minus 2. So we know that to be 4 and what? 2. Since I need a negative 2, the bigger factor must be what? Negative. So in this case, I have my x squared minus 4x, then plus 2x minus 8 equals what? 0. So you'll be taking the common factor in the first bracket. Obviously, we have x minus 4. Common factor will be 2. X minus what? 4 equals to 0. So to continue this, we are going to have outside. Then this is a common factor. So x minus 4 all equals to 0. So either the first bracket is equal to 0 or the second equals to 0. The identity or 0 identity. So we are going to have x plus 2 equals to 0 or x minus 4 equals to 0. You know from here I'll have x equals to minus 2 or x equals to 4. Now under logarithm, we don't have logarithm of a negative number. So this is, if we are saying our x, it means the first equation to be log negative 2 base 2. And we don't have a logarithm of a negative number. So we reject this answer. So therefore, our x is just going to be what? 4. We have to reject any answer that gives us a negative value. So this will be the answer we are going to get if we are to solve this equation. Alright. For the second aspect, which I will say the second method, we are going to move all the way to this place. You can see that this, as I am seeing, is also can be expressed as a logarithm. Don't forget the property of an identity says that if I have log of a to the base a, I have what? 1. And we also have the power rule, meaning if I have 3 out there, log 3 exponent 3, log a exponent 3 over a, I can still write this as 3 log a base a. And you can see that log a base a will cancel to give you only what? 3. So I can do same from this expression. I can convert this to become a logarithm of equal argument and base. So in this case, this is going to be log x squared minus 2x base 2 equals to log 2 exponent 3 base 2. Don't forget we are in base 2. So this will be in base 2 in order for me to get this to be 1. So that can be written as log x squared 2x base 2 equals to log 8 base 2. The first method says that if I have a single logarithm at both sides, the logarithms of equal base are going to cancel out. So I'll be left with only x squared minus 2x equals what? 8. And you can see from here, I'll move my 8 in to give me x squared minus 2x minus 8 equals 0. And I'll end up getting the same answer. I believe you get the concept. So these are the two methods. Find it educative, please. Don't forget to hit the like button, share, comment, and subscribe if you have not subscribed to the channel. Thank you so much for watching.